Hello everyone. My name is Meena Bugatha and from the Department of Artificial Intelligence and Machine Learning from St. Joseph College of Engineering, OMR. So, today we are going to see a topic on programming problems in convex optimization. So, optimization means where we actually have a lot of solutions, but we conclude with a best solution. That is called optimization. So in that optimizations, we are going to see a problem which is under convex optimization. So in programming problem, we have two types of problems. One is linear, another one is non-linear, which is called as LPP and NLPP. So in LPP means a linear programming problem where objective function and convex functions, constraint function, which is convex. So constraint functions and linear functions are in linear, whereas in NLPP, the constraint functions and objective function, it is not in linear. In NLPP, we have three subdivisions. So one is geometric programming problem. Another one is convex programming problem, which is also called as quadratic programming problem. And third one is vector optimization. So under NLP, non-linear programming problem, we have three types. One is geometric programming problem. Second one is quadratic programming problem. Third one is vector programming problem. So I'm going to solve a problem which comes under geometric programming problem. The problem structure is like solve geometric programming problem with a function f is equal to 5x plus 20x2 plus 10x1 to the power of minus 1, x2 to the power of minus 1. So this is our structure of vector function. So we are going to solve this function. So first we have to segregate each terms which we have. In this question we have three x terms, which is x1, x2 and x1, x2. This is one pair, this one is second one, and this one is third term. So for the first, second and third term, we are going to formulate a formula, which is u1 plus u2 plus u3. So u1 means the first term, u2 means the second term, u3 will be the third term. So usually the first term will be in your question, u1 is equal to 5x1, u2 is equal to 20x2, and the third term will be this pair one, 10x1 minus 1, x2 minus 1. So we are going to present, we are going to substitute these terms in this formula. This formula is specializedly from the which we use for geometric programming problem. So that formula is u1 plus u2 plus u3, which is greater than or equal to u1 divided by dou1 to the power of dou1, u2 divided by dou2 to the power of dou2, and u3 divided by dou3 to the power of dou3. So this is the formula. We are going to substitute each term in this formula and going to get the best solution. So this is how we solve the geometric programming problem in short. So I will be explaining in detail by substituting all the terms. So now, from the question, we are going to segregate each terms. So first term is x1, second term is x2, and third term will be x1, x2. So we are going to substitute all those terms in this formula. So I have mentioned each term separately. So I'm going to substitute all those terms in this formula. Here how it looks. When I substitute u1, it will be u1 term is 5x1. So 5x1 divided by dou 1 into dou 1, and u2 term will be 20x2. So I'm substituting the u2 term in this formula. It will be looks like 20x2 divided by dou 2 to the power of dou 2. And the third term is all those terms are in a product. So we are not going to add or subtract. We are going to just multiply all those terms by segregating in a different way. So the third term is u3 divided by dou 3, the whole power dou 3. So the dou 3 term is, u3 term is 10x1 minus 1, x2 minus 1. So I'm just substituting the term divided by dou 3, the whole power dou 3. So what I'm going to do is now, I'm going to just segregate the x terms in one side and remaining dou terms in another side. So if I take all those x terms outside, it looks like x1, x2 and then x1, x2, which comes along with the power. So dou 1, dou 2, dou minus dou 3 and minus dou 3, because here it is x1 minus 1 into dou 3, which means x1 minus dou 3 will be x1 minus dou 3. So that I have directly mentioned here. So x1 minus dou 3, x2 minus dou 3. So remaining terms will be remains here. So remaining term is like 5 by x1. Here I have separated the x1 term. So remaining terms is 5 divided by dou 1, the whole power dou 1, 20 divided by dou 2, the whole power dou 2, and 10 divided by dou 3, the whole power dou 3. So dou 3 is the common term for x and the u term also. So we have two dou 1 and dou 2 and dou 3's. Okay. Here you have to mainly focus on the symbol which is greater than or equal to. It should remain at the end of the problem. We are not going to take any action. We are going to compare the right hand side with the left hand side. Okay. So here we are going to combine the x terms. x1, x1. So I'm having for x1 and here x2 term. So what I'm going to do is the base are equal. So I'm going to combine the powers. So x1 power will be dou 1. So I have to take the dou 1, and for the another x1 term, my power is minus dou 3. So what I am going to do, if it is in a positive way, it will be dou 1 plus dou 3. But here we have minus dou 3. So if we merge the powers, it will look like dou 1 minus dou 3. And the second term is x2 dou 2 and x2 minus dou 2. So we have two dou 2's. So what I'm going to do, I'm going to again merge, because base are same, power going to be merged. So x2 is the base and powers will be dou 2 minus dou 3. So we sorted out the x1 and x2 terms. Remaining terms we just put as it is in the above step. So 5 by dou 1 to the dou power remaining dou 3 terms. So this will be the first equation. As we know, dou 1 is equal to dou 3 and dou 2 is equal to dou 3. So what I'm going to do is, I'm going to substitute instead of dou 1, I can substitute dou 3, or else instead of dou 3 I can substitute dou 1. So what will happen? The base will remain the same. The power will be dou 1 minus dou 1, which means 1 minus 1, which is zeros. In the same way, x to the power of 0, which is 1. So we are going to substitute as per in this way we know. Okay. let dou 1 dou 3 equal to 0, dou 2 dou 3 is equal to 0. So now, as we segregated the x terms and u1 terms, u2, u3 terms, and then as we know, like we are simulating and we are just including our powers, like dou 1 is equal to dou 3, dou 2 is equal to dou 3, just substitute those terms in the same similar terms, we get 0. Power will be 0. Then base, if base is x1 to the power of 0, it will be considered as 1. So we are going to substitute those terms in the first equation. So as we know, like dou 1 minus dou 3 is equal to 0, dou 2 minus dou 3 is equal to 0. So when I add all those similar terms like dou 1 plus dou 2 plus dou 3 is equal to 1. So what will happen? It will be considered like dou 1 plus dou 2 will be dou 1 plus dou 3 will be dou 1. So I have 3 dou 1s. So if I add those dou 1s, I will be getting 3 dou 1 is equal to 1. And then I'm just moving the third, I'm just moving the 3 to the right hand side. Then it will be considered as dou 1 is equal to 1 divided by 3. Okay, so the same in the same similar way, if we do for dou 2, it will be 1 by 3. If we do for dou 3, it will be 1 by 3. So dou 1 is equal to dou 2 is equal to dou 3 is equal to 1 by 3. So we can substitute 1 by 3 for all the 3 terms. Okay, so substitute in the first equation, which is this one. Okay, so the same symbol, greater than or less than, what we mentioned in the above first step, we have to continue till the last one. We are not going to touch those symbols. Okay, so greater than or equal to, now x1 will be 0, x1 base power will be 0, x2 base power will be 0, and the u1 term will be remains the same 5, u2 terms remains the same 20, and u3 terms remains the same 10. Instead of dou 1 to the power of dou 1, we are going to substitute 1 by 3. So dou 1 will be 1 by 3 and power will be again dou 1. So we are going to substitute, instead of dou 1, we are going to substitute 1 by 3. So base denominator will be 1 by 3, power will be 1 by 3 for all the dou terms. So 1 by 3, 1 by 3, 1 by 3, 1 by 3. So I'm just saying that like we are going to merge all the, if the base are same, we are going to merge all the powers, and instead of the ones, we are just adding 1 by 3 for all the those. So again the symbol, so base x1 to the power of 0 will be 1, dou 2 to the power of 0 will be 1. So 1 into 1 again 1, so no need to mention the 1, so 1 here, which is a positive value, so no need to mention here. And remaining terms, if I solve this example, 5 divided by 1 by 3 into the 1 by 3, it will be getting 15. and 20 divided by 1 by 3 to the power of 1 by 3, we will be getting 60, and 10 divided by 1 by 3 to the power of 1 by 3, we will be getting 30. But what I am going to take is, I am going to solve the numerator and denominator and merging all my powers, because the powers are same. So I am going to take the power out, which is a common element for all the terms. So 15.60.30, the whole power 1 by 3. If this is the product one, this is not having plus or minus. So if I multiply all those three terms and then powering my 1 by 3, which is the power of 1 by 3, I will be getting 30. So f of x is nothing but my objective function, OF. This comes under non-linear function, where our objective function and constraint function is not in linear. So we are going to prove that. That is the conclusion of this problem. So here f of x is objective function, which is 30. At the end, sorry, at the end I'm getting 30 value. So the minimum value is 30, which is objective function is greater than or equal to 30. So this is the conclusion of one part, and we are going to substitute those part in the another one. Now we are going to find the x1 and x2 term. So what I am going to do, before that we producted the u1 terms, but here we are going to compare all those u1 terms. u1 is 5x1 divided by 1 by 3, u2 is 20x2 divided by 1 by 3, u3 is 10x1 to the power of minus 1, x2 to the power of minus 1 divided by 1 by 3. So what I am going to do now is, first I'm taking this x1 term and x2 term and solving this. I'm getting x1 is equal to 4x2. So what I'm going to do is, using this x1 term, I'm going to substitute all those and I'm going to find my x1 and x2 terms. So now I'm taking the second one, 2x2 is equal to 10x1 to the power of 1, x2 to the power of minus 1. Okay, so here what I'm doing is I'm going to cancelling out 10 one times and 10 10 twos are 20. So right, so 1 time and 2 times. So here how I got my 2x2. So 2x2 is equal to x1 inverse x2 inverse. Okay. Now we are going to solve this. Okay. So we are going to simplify this. So 2x2 is equal to, so we have here minus 1. So how can I take it in a positive way? Means 1 divided by x1 and x2. It will be same as x1 inverse, x2 inverse. So 1 by x1 and x2. And then x2. Here I am going to take this x1 and x2 in the denominator and moving it in a right hand side. So left in left it will be division. In right, if we move this division into right, it will be in a up and down. So 2x2 and x1 x2, which means 2x2 into, this will be denominator will become a numerator. So x1 x2. So now I have 2 x1 and x2 term, 2 terms, 2 x2 terms. So 2 x1 x2 to the power of 2 equal to 1. Okay, and then what I'm going to do is I'm going to substitute the x1 term, which we already assumed that x1 is equal to 4x2. So we are going to substitute the x1 in this one. So 2 x1 will be 4x2 and again x2 to the power of 2 is equal to 1. Now 2 into 4, 8 x2, and already we have x2 to the power of 2. So we have the base power, then we can merge the powers. So 8 x2 to the power of 2 plus 1 will be 3. So 8 x2 power 3 is equal to 1. So here I have solved, like if we have this, x2 will be 1 by 2. Obviously, if I move the 8 to the left hand side, it will be 1 by 8, and then if I do all the 3 powers, it will be x2 will be 1 by 3. Okay. So now we have x2, a solved term, single term. Now going to substitute in the x1 term. So x1 will be 4x2. So x1 is equal to 4x2. Substitute the x2 term 1 by 2 in this one. 4 1 by 2. So now we can easily cancel the term. So 2 ones are 2 twos are. So 1 and 2. So x1 will be now 2. So now I have x1 term and x2 term. x1 is 2, x2 is 1 by 3. And my function is the minimum value which we found in the previous step is 30. So x1 is 20, x2 is 1 by 2 with the minimum value 30. So this is the conclusion of the programming problem of geometric programming problem optimization. So why we found all those solutions is to prove that the solutions is minimum than the objective function. So which have we got is 30 x1 and x2 terms, which is comparatively lesser than the minimum value. So how we solve the geometric function in short is, we have to take the values, we have to segregate the values u1, u2 and u3, and then we have to substitute in the formula, which is less than u1 divided by dou 1 to the power of dou 1, u2 divided by dou 2 to the power of dou 2, and u3 divided by dou 3 to the power of dou 3. We have to substitute and find the minimum value. This is the first step. In the second step, we have to compare all the u terms. So what will be the formula? Means u1 divided by dou 1 equal to u2 divided by dou 2 equal to u3 divided by dou 3